Good evening. How's everybody doing? Just checking that the live is in the group. If you're online, come and say hello. Oh, there I am. Right, so I'll open this up so that I can see any questions and comments as we go. So do let me know if you're here. You can give it a little like or a comment so that I know who I'm talking to. If you're watching later, then do feel free to do the same. Um, I'll reply to anything that you ask as we go. If you're watching along, you probably want to get a paper and a pen and have a go at the questions and write down some notes. If you're watching along later, do the same. And if you have any questions, you can ask them in the comments and I'll get back to you as we go or later on. So the lesson today is actually designed to carry on from the lesson that we did last week, talking through geometry terms. Um, I'm adding in a couple of extra ones this time. So I'll just share the screen and you can see that. Here we are. You should be able to see the slide cover. So today again, going through some geometry terms. You can remember the ones that we did last time. It's introducing some geometry terms. Now we're moving on to the next ones on the list: parallel lines, perpendicular lines, and right angles. So if you already know what those things are, you can add that into the chat, or you can just give me a thumbs up to say that you already know what those ones are. We're going to go through them in the slide today, and I'll share some practice questions around them. Now, these lessons are aimed at foundation maths students, so there are some additional questions that you might find for perpendicular lines if you're doing the higher tier paper, but I won't go through those ones today because I wanted to make it inclusive for everybody's exam. So everybody would have to study the foundation content and only the higher tier students would have to study the higher tier content. So we'll just go through the foundation content today. So the key terms, I would suggest writing these ones in your notes, and then we can add to them as we go, as you define them. So just on a piece of paper, write down with the big space between them, parallel lines, perpendicular lines, and right angles. And if you already know what those are, brilliant. You can have a go at writing in the definition. But first, before you do that, let's write down all three of them so that you get them into your notes before we move on. If you don't know what they are, or you're not sure, that's fine because we're going to go through them now and I'll share with you the definitions. So parallel lines, perpendicular lines, and right angles. So what are parallel lines? The parallel lines are two or more straight lines with the same gradient, and they'll continue indefinitely without ever crossing over. So that picture is an example of two parallel line segments. They would continue forever and they would always be at the same distance from each other, so they will never cross over each other. So looking at that definition, two or more lines with the same gradient. What is the gradient of the line? What does it actually mean when it says gradient? So the gradient of a line is a measure of how steep it is, a measure of the slope of the line. And when we're actually measuring it to give it a mathematical value, we would measure the change in the y-axis divided by the change in the x-axis. Remember, the y-axis is this way, the x-axis is this way. So vertical y-axis, horizontal x-axis. So it'll be the change in this value divided by the change in this value. This one, because of the way it's going, that will be a negative slope, because as the x is increasing from left to right, the y is decreasing from top to bottom, so that would be a negative slope. That doesn't matter for this example. Just defining what the gradient is so that we know what that line definition means. Perpendicular lines then. What are perpendicular lines? The perpendicular lines are two straight lines at right angles to each other. You can also have perpendicular objects, things that are at right angles to each other. If you're someone who likes to keep their desk nice and neat, maybe you like to keep everything perpendicular to everything else on your desk, which just means that everything is moving in the same lines, all the angles that you have between your objects are right angles. Just makes everything neat. But for mathematical purposes, it tells us properties about those lines. So we've got an example in the diagram there, two straight lines at right angles to each other, which then brings us on to our third definition, which was right angles. A right angle is a 90-degree angle. So if two objects are at right angles to each other, then one is 90 degrees to the other. If you can see here, we can actually see two 90-degree angles, one on the left and one on the right. Does that make sense? Do these lines have the same gradient? So we said that the gradient is calculated as the change in the y-axis divided by the change in the x-axis. It's a measure of how steep they are, or a measure of their slope. These ones are going in two different directions, so they can't have the same gradient. Okay, the gradient is always relative to the axis on the page, and if they're not going in the same direction, they can't have the same slope. So they have one set of axes. The actual measure of the gradient between the two is using that equation, which you don't need for foundation maths, but for those curious, I have included it. You can calculate the gradient of the perpendicular line from the gradient of the line that it is perpendicular to, using that equation, but you don't need that. So add to your notes, what's the definition of a parallel line? What's the definition of a perpendicular line? And what's a right angle? And you could include those diagrams to help make it clear. Or you can be inventive and create your own illustrations. If you're watching this later, you can pause to make sure that it goes at your pace. You can rewind to get the definitions and add them in. I'm going to carry on and look at some example questions to see how we can use that. So practice questions for a foundation exam would be along the lines of this. So you have equations of a straight line. So an equation of a straight line always looks something like this, where you have y. I've misplaced my graphics pen already, even though I've literally just been using it. So I'm going to have to get creative with my mouse, so it doesn't matter. No, I won't. I will. Bear with me a moment. I don't need to get creative at all. I shall share my whiteboard and do it on there. So that's going to move up there. Right, so the equation of the line, of a straight line, always looks like this. That's very small, isn't it? Anyway, the equation of the line would be something like that. Y equals mx plus c, okay? So y and x are talking about the coordinates, the x and y coordinates at the points on that line. So x and y will always be in your straight line equation. Sometimes you might call them different things. If you're talking about a specific example of a linear relationship between two things, they might get given names, and those names might give them different letters, but they are still the x and y coordinates, so we can refer to them as the x and y. And they'll always have this value multiplier in front of the x, which is where the gradient of the line goes, and then they'll have a number added on the end, which is the y-intercept. If it doesn't have a number added on, it means that the intercept is the origin of the line, so it goes through 0, 0. So there's no value to add because it's 0. If there's no number in front of the x, it means that it has a gradient of 1. And when it's a multiplier of 1, we don't bother putting that in because it does not change the value. So we can take from the equation of a straight line the value in place of the m so that we know exactly what the gradient of the line is. So that means that we can compare the equations of two lines to work out whether or not they're parallel, because if they're parallel, remember, they have to have the same gradient. Hopefully that makes sense. Despite me losing my notes. Okay, so we were looking at this one, gives the equation of a line that's parallel to the equation y equals 3x plus 4. So if it's parallel, it would have to have the same gradient. So the examples that you can give are infinite, but it would be anything that starts y equals 3x, and then the y-intercept, the number that you add on, can be anything that you like. So it could just be y equals 3x. That would be an equation of a line parallel to the line we've got here that goes straight through the origin. Could be y equals 3x plus 7,421,000,000. That also is parallel to that line, but quite a long way away from it. So the second one shows us a different equation. Give the equation of a line that's parallel to the equation 2y equals 3x plus 4. So for that one, it's not in the format that we can read the gradient from it directly. I'll just type it in here, 2y equals 3x plus 4. We can't read the gradient from that directly because it's got a 2y and not a y, which means that the equation of the line has been doubled. So before we can read from it, you can't see that until I come out. Before we can find the gradient, we have to divide everything in there by 2 to cancel out the 2 in front of the y. So if we divided everything in there by 2, the 2y would become y, which is what we wanted. The 3 would become 1.5, and the 4 would become 2. So that would be the equation of the line. And then if you read from that the gradient, it's actually 1.5. So if we go back to our question over here, if you go back to the question, the equation of the line that's parallel to that has to be y equals 1.5x plus something, plus whatever you like. Okay, that's why that one's 2 marks, because first you have to rearrange the equation and then read from it the gradient. Those questions that I've shared there were taken from the Maths Made Easy website. So if you wanted to have a look at more notes and questions, I'd recommend having a look at the Maths Made Easy website. And there are also online exam questions around that you can have a go at, because it does mark them for you as you go, so you don't need feedback for it. If you do find you're stuck with any of them, then take a screenshot and add it to the comments here, and I'll be happy to help you with it. That is as much as you need to know for the foundation exam on parallel and perpendicular lines. The only thing that you would potentially have to do otherwise is to draw them, which is in a separate topic on constructions, which we won't do today because you won't be able to see me doing it. But hopefully that means now that you understand what parallel lines are, what perpendicular lines are, what right angles are, and some examples of the exam questions that you might see on those. If you found this lesson useful today, I'd be really grateful if you could leave a recommendation on Facebook, or share the group with anybody that you know that would find this useful. And if you need any additional support with your maths revision, then send me a message to inquire about booking some one-to-one tuition support. Have a lovely rest of your day, and I'll speak to you again soon.